evening, everyone. I'm Paul, and I'll be conducting your week 8 problem solving and doubt clearing session. So today we will be considering about the graph theory, how we apply it for the network analysis, how we will consider some various aspects of that we will look into today. So let me share my screen. So you guys are able to see my screen? Okay. Yeah. So today we'll be considering week 8. And basically it deals with graph theory. So can anyone tell where do we use graph theory? Does anyone know? Huh?
To analyze the frequency response or in control system that
Control systems, how do we use graph theory? I'm not exactly sure. Like, could you elaborate a bit on it? How? The frequency response of the system.
is a frequency response of the system that can be like in circuits will analyze the frequency response to measure the bandwidth, and circuit in control systems we can use that to that to to calculate the transient response.
Okay. No, like, are you talking of that that block reduction method? That one?
Yes.
Okay. Like, I don't exactly know frequency response. Whether how we can use graph theory for frequency response, I don't know. But like overall, like graph theory is a very vast subject, and it is mainly used where we have a lot of interconnections. Like you have some A, B, C, you have D, E. This is connected here, this is connected here, this is connected here, this is connected like this, this is connected like this is connected like this is connected like this. Okay. So suppose we have such a network, okay? So many connections are there. Then how do you solve it? So that's why people have come up with graph theory to find a systematic way in which you can solve such things. So in our context for electrical engineering, as we are doing network analysis course, so we will be considering it with respect to our electrical circuit elements. So basically, what are the electrical circuit elements which you have used till now?
Resistor, inductor, capacitors.
Okay. What about Kavya? What about Shubhakam? You guys are not using anything? Huh?
And batteries also.
What?
Apart from this, batteries, power supply,
Okay. Power
current
supply.
sources and
Okay.
voltage sources.
Okay. So there could be current sources, voltage sources. So like graph theory also in a broad perspective, it is used by by computer science people a lot. Like Google Maps, etc. Like those are just graphs. From one location, you're going to another location. All these things. Okay. So there are many ways you can make graphs, etc. You can analyze graphs. So we will be considering it for our electrical circuit, our network elements. So in the graph which we have for electrical networks, we have points. The points which we have, they are called nodes. Okay, they are known as nodes. Okay. One more thing is these blue things, which are the nodes, which we will consider, they should have at least 3 connections. They should at least have 3 connections. So in this case, this cannot be considered. This is not something separate. This is not something separate. You cannot consider this. Okay. That is one limitation. All right. Now, so we have, let us assume, let me draw one network. We have some resistor here. So, how many nodes are there in this circuit?
5 nodes.
5 nodes. Which and all?
A middle person
Sir, I think 4
and the
nodes.
outer person.
That's what I'm thinking. There are
The 3 nodes.
Yes, sir, 3 nodes.
okay, there are actually 4 nodes. This is one node, this is another node, this is another node, and this is another node. This is the same point. No, one, same point, same point, same point. So effectively there are only 2 nodes. Sorry. So So there is this node and this node. Only 2 nodes are there. If you see, let me draw this in different color. This is one node. These 4 points are actually the same point, right? They're just connected by a short. So it's basically the same point. Is there any doubt in that? Okay. So, okay, so I see I took a poor example. Let me draw another example. So for this network, how many nodes are there?
2.
2 nodes. Which are those 2 nodes?
Sir, in between R2, R5 and R4, and then another is in between R1, R2 and R3.
Okay. So these are the 2 nodes, right?
Yes, sir.
Now suppose I add one more connection like this. I add a current source over here. Now how many nodes are there?
4.
1, 2, 3, 4.
4. This node, this node. So you have 4 nodes, right?
Sir, there is sir 4 junctions, not nodes.
Sorry.
Sir, node is a point where 2 or more elements are connected, and junction is a point where 3 or more number of elements are connected. Every every junction is a node, but all the nodes are not junction.
Correct. No,
So in this case,
uh,
in this case, uh,
no. In this case also,
in
this
this
is
case there is 4. In the previous case, sir, in the previous case, when there is no current source, when there is no current source, there will be 2 junctions, sir. But there is 4 nodes. Sir, if we are omitting the current source, there is 2 number of junctions
okay.
and 4 number of nodes.
Okay.
Now in this case, there is 4 number of nodes and 4 junctions.
Okay, we'll look into this definition, because to what I understand is these are all nodes. All these are nodes currently in this circuit
All these
configuration.
are,
These are all nodes.
yes sir, all are nodes, sir.
Yeah. Okay. So now,
Where 2 or more elements are connected, that point is a node.
okay. So, check that. We'll see, look into that later. So now, suppose you have drawn this, your circuit is there, and you have four nodes are there. So now, if you want to represent it in graph theory, as sir also would have taught you guys, what you do is you draw the nodes first. You first name the nodes. Let us name it as A, B, C, D something. Okay. So I will draw A, I will draw B, I will draw C, I will draw D. Now I will draw the connections between them. There's a connection from here, there's a connection from here, there's a connection from here to here, another connection from here to here, from here to here, as well as from here to here. Okay. Now I've drawn the connections, but what is in that I am not specified. Now I must give the connection some names. So let us say this is 1, this is 2, this is 3, this is 4, this is 5, and this is 6. Okay.
Yes,
So I have given some connection, I have given name each connection, given it some particular value, as well as I have also given it some direction. So it is like a directed graph. Okay. Further, this graph, it has how many elements are there?
6 elements.
Okay, so first we'll write the number of nodes. And how many number of elements?
Number of elements is at 6. Number of nodes is 4.
Okay. Number of nodes is 4, number of elements is 6. All right. Then one more thing is each of these will have some particular voltage and some particular current through each element. Let us consider element 1. This is element 1. Okay. It has some voltage and some current. So this is your current direction. Then your voltage notation in terms of graph theory, this will be plus, this will be minus. So this will be VE1. Okay, so your current is flowing from the point of higher potential to lower potential. Okay.
Yes, sir.
So this is your VE1. Similarly, for each and everything, these voltages and currents are inherently meant when you draw these arrows. Okay. When I draw the arrow, I imply that over here there is plus, over here there is minus. So this is my VE5 voltage across my fifth element, and this is my current IE5 will be flowing in this direction. So is there any doubt in this?
No, sir.
Okay. Yeah. So to avoid making it look very awkward and very clumsy, etc., we avoid adding the notations of voltages and currents, but those are actually implied. So that's why we just use an arrow and we call that as a directed graph. Now, let's see. So what will be So have you guys studied tree for this? What is a tree?
Uh, set 3 is the part of this loop which does not make any loop. It covers all the node points,
Okay.
but it does not make a loop.
Okay. So let us
It
draw
covers
some.
all the node points.
Mhm.
It covers all the node points, but not make a loop.
Okay. Let me redraw it again. Okay, this is the thing. So how many, can you draw one tree? Can you tell me one tree?
Sir, A to B, B to D, and D to C. One tree. A to B, B to D, D to C. B to D, D to C.
Okay. So what is a tree? Tree is a connection. That is, there is a path where we are going from, where it is connecting each of the nodes. But there is no closed path. There is no loop. A loop is not formed. Okay. So
Yes,
can
sir.
you tell me another tree for this? Okay, last one
A
more.
to
Let another person tell. So Narasimha, can you tell me one more tree?
Sir, from D to C and no, sir,
What?
that will also be a loop. No, there are. I think there are no three.
Okay, from D to C, then from where should I go?
Sir, again, if we go from C to A, again that will become a loop. So that's it. I think.
No, let us go. So you're saying we go from C to A. Okay, then where should we go?
Then uh, it will become a loop, sir. If you come back to B and then to D, there will be a loop. No, sir, that is not possible. Sorry, sir.
No, no, it is
That will
possible.
no,
become a
sir.
loop.
It is possible.
Sir,
If we
we are
just go,
coming from A to D and D to B.
then it is fine now. So we have gone from, I have gone from node D to node C to node A to node B. I have gone, but I haven't
Sir,
made a loop, right?
but still
Yes.
there is a connection between B to D. Can we shouldn't we draw that?
No, if you draw that, then it will become a closed path. No, if you say, if I draw this,
Yes, sir.
wait, the color is not same. If I draw this, then the path is closed, but that is not allowed. In a tree, that is not permitted. So that's why I'm not permitted to draw. But I have a tree is formed when you're connecting from one node to the next node. To all the nodes should be connected, but a closed path should not be formed. That is called a tree.
Okay, sir. Thank you, sir.
Yeah. So okay, another example of a tree. 1 minute, let me ask someone else. So
A to B, B to C, B to D. T section.
1 minute, let someone else share. So Kavya, tell me another example of tree.
A to B, B to C, and C to D.
A to B, B to C, and C to D. Correct?
Yes, sir.
Yes, sir.
Okay. So like this, how many possible combinations can you make?
One, two, three, four, five. A six combination.
How many?
Six combination.
Only 6. So I don't know the exact
7.
number, but I don't know whether it is so less also.
This
Uh-huh.
after drawing.
Sorry.
After drawing all the trees, then you can say you don't know any shortcut method to how to find the number of trees.
I think there is something, but I don't remember. So you guys can check. Okay. So now this is a tree. So what will be a code tree for the tree? This is my tree. Now there's something known as a code tree. Okay. So
Yes, sir.
one more thing is each element of a tree. What are they called?
Twigs.
Twigs. Yeah,
Twigs.
they're called twigs. Okay. So now these trees have how many twigs?
A tree.
And how many nodes are there?
4.
4.
Okay. So that means how many, what to say? So what's the relationship between the number of twigs and the number of nodes?
Number of twigs is equals to number of nodes minus 1.
Correct. So the number of twigs is equal to the number of nodes minus 1. Okay. So let us consider I take a tree which is given by like this. I take one tree. A, B, C, D. Okay. Now this is my tree. What will be my code tree?
A code tree can be represented by dotted line.
Okay. Where will I draw the dotted lines?
Between the node
A
points.
to D, D to C, and A to C.
Okay. A to D, D to C, and C to A. Right?
Yes.
So
Okay.
what is the direction? This is 4. This is 6 and this is 5. Okay. So what are these? So how many elements are there in the code tree?
3 elements.
And what is an element of a code tree called?
Link.
Link.
Link. So okay. So now we have established word tree. We have established a code tree. So if there are many number of trees available, how do we select which tree to choose? Because see, if you come over here, there's 1, 3, 2, 3, 3, 3. Which tree should I choose? How will you? Which is preferable? .
Sorry, sir, don't know.
Okay. So usually they advise to select the first three, 1, 2, 3, serial number wise. So it makes the matrices everything easier. Okay, in solving. Okay.
Yes, sir.
So now, so the number of links is equal to the total number of elements minus the number of twigs, right? Any doubts in this?
No, sir.
This is E minus N minus 1. Number of twigs is N minus 1. That is equal to E minus N plus 1. Okay. So this is how you can calculate the number of links and the number of twigs, etc. Here, how many are the number of elements? How many elements are there?
6.
6. Nodes are 4. So the number of links is 3, which is as per our equation. Okay. So this session will end in 10 minutes. Then I'll restart this session and you can rejoin the meeting again. Okay. So now, what is, you guys have studied about matrices?
Yes,
What are,
sir.
why do we use that?
In incident matrix, we are using the KCL.
Okay.
In constant.
In concept what?
In Tyside matrix, we are using the KVL.
Okay.
And in constant matrix,
We are doing KCL of the concept. Okay.
in KCL in constant, but in some portion of the network,
Yeah, we are cutting the network into two, right?
not at the node points. Yes, sir.
Okay. So now, but why do we use a matrix? Why do we use a matrix? Who can tell me?
Write the equation, sir.
To write an equation. Okay.
Yes, sir.
So assume, so now let me draw it again. It's going away. Can you find the KCL for each of these nodes? This is IE1, IE5, IE6. Can you find KCL for this?
Yes, sir. In node A, I1 minus I5 minus I6 equal to 0.
Actually, this should be drawn somewhere close by. Okay. Okay, let us do KCL of node A. So what is KCL of node A?
I1 minus I5 minus I1 minus I5 minus I6 equal to 0.
So how did you decide which is plus and which is minus?
Sir, we take the outgoing as the positive, so all the incoming are negative.
So outgoing is positive, all the incoming are negative. So what is KCL of node B? Another person say, so Akash, what is KCL of node B?
I3 minus I3 plus I.
I3 plus I2?
I2 minus I1 is equals to 0.
Okay, so it
I3
actually
plus I2 minus I3 equals 0.
I3. Hello?
I3,
Huh?
can you hear me?
Yeah, I can hear.
I3 plus I2
Hmm.
minus I1 equals 0.
Okay, correct. So it is I3 plus I2 minus I1. So it is minus I1 plus IE2 plus IE3 is equal to 0. This is for node B. Okay. Now for node C,
Yes.
what you'll get? So let me ask someone else. So who's that guy? So Narishma,
Yes, sir.
for node C, what will be KCL?
Sir, I3 plus I4 minus I6 equals to 0.
How did you decide plus or minus?
Sir, because the current coming into the node is taken as positive and current going out from the node is taken as negative. If we take the reverse, the signs will get changed.
Okay, so which one? There are two options. Which one should I take?
So previously you took the second option, so it would be, I'm sorry, yeah, it would be, I think, minus I3 minus I4 plus I6 equals to 0.
Okay, correct. So it will be minus IE3 minus IE4 plus IE6 is equal to 0. This is for node C. Now for node D, what it will be? So let me ask someone. So Kavya, you tell me. For node D. Hmm?
Sir, I5 plus I4 minus I2 equal to 0.
What? Can you repeat again?
I4 plus I5 minus I2 equal to 0.
Okay, so that's why I write. First, I will write the lowest number. So I write minus IE2 plus IE4 plus
4
IE5
plus
is equal
I5
to 0.
equal to 0.
So you must, I will advise you must write it in the order in which 1, 2, 3, in that ascending order you must write it. So it becomes easier when you
Yes,
want
sir.
to write the matrix. Okay. So if you write the matrix, how will you write a matrix for these? How many equations are there first of all?
4 equations.
4 equations. And how many variables are there?
Variables are 6
6
variables, sir.
variables.
Okay.
6 variables.
Okay. So there are 6 variables. All right. So now, how will you write it in matrix form?
Sir, I1, I2, I3 column matrix into row elements 1, 0, 0, that equal to 0.
Sorry.
Sir, first we write the column matrix of IE, IE1 to I6
Okay.
into 1, 0, 0 as per the value that equal to 0.
Okay. So that is, oh no. 3 into 6 matrix, fine. So you tell me where will the matrix be? Like this is you're saying column matrix, IE1, IE2, like this.
Yes, sir, yes, sir.
IE3, IE4, IE5,
IE5, I6,
IE6. This is the
yes,
matrix.
sir.
Where will 1, 0 all that come?
Yes, sir. Then 1, 0, all that come.
Can you tell? So it will become here.
Sir, in first case, in position, first number is 1.
1.
First number is 1. Fifth number is -1. Sixth number is -1, and all the other 0.
So it'll come like this.
So first
Yes,
we'll
sir.
get those numerical values. And
One,
then we'll
one,
get
0, 0, 0, minus 1, minus 1.
Okay, actually, so first in matrix multiplication, there is something known as dimensions also, which are very important. So I'll touch upon that. So this is, yeah. First of all, there is something known as matrix. So let me just tell that. So matrix multiplication is very important, okay? I'll just try to highlight it a bit. Assume you have matrix A. Okay, you have matrix A. You are multiplying it with matrix B. So what is the dimensions of matrix A? How do you write it as?
M cross N.
M cross N.
Okay, so A, you are saying it has dimensions of M. Okay. A has dimension M cross N. M is what?
Row, number of
Number of
rows.
rows.
So this is number of rows, right? N is what?
Number of columns.
Number of columns.
Okay. Now B. So let us give this A
N cross
N1. Okay. Now B. So B has also some dimensions. M2 cross N2. So M2 is the number of rows and N2 is the number of columns. Okay. Now, if I want to do matrix multiplication, what should be the relation between the rows and columns of matrix A and the rows? Okay, A into B becomes some equal to some matrix C. Okay. C also has some relation M3 cross N3. These are the number of rows of C and these are number of columns. How do I get M3 and N3 from this?
M1 will be M3 and N2 will be N3.
So you're saying M3 will be equal to M1 and your N3 will be equal to N2, right?
Yes, sir. And N1 and M2 should be equal in order to
This
multiply.
is very important. N1 should be equal to M2. If this is not satisfied, then you cannot do matrix multiplication. Only if this is satisfied, then you can do matrix multiplication.
Yes.
Okay. So I'll go over again. Suppose I have A cross B equal to C. A has M1 into N1, B has M2 into N2, C has M3 into N3. So first condition is I must check if this number of rows is equal to number of, if this number of columns is equal to the number of rows. Only then matrix multiplication is possible. Okay, I check that. If it is possible, then the matrix multiplication will come out to be C, and the number of rows will be equal to this one, and the number of columns will be equal to this. Okay. So this is a very important thing which you must remember. So, Kota and all, you have any doubts in this?
No, sir.
No, sir.
Okay. So now, let us go to this one. So what is the dimension of this matrix?
6 cross E1.
6
1
cross,
cross 6 cross 1.
and this one?
6 cross 6.
This one is 6 cross 6.
3 cross 6.
3 cross
4
6.
cross 6.
It is 4
4
cross
cross
6.
6.
Because there are 4 rows. 1, 2, 3, 4. 4 equations. No? So 4 rows. Right. So can I do matrix,
Yes.
matrix multiplication? Can I do it over here?
No, no, sir.
So there's a mistake over here. So in actual reality, what should be done is, I'll rub this off. Okay. this should be this side. This will be this side. I1, I2, I3, I4,
Yes, sir.
5, I6. Those are all equal to 0. So we have 4 zeros, 1, 2, 3, 4. And this we have to fill up. So what
Yes,
will
sir.
be the coefficient of this first row?
So 1 0 0 0 minus 1 minus 1
1, 0, 0, 0, minus 1,
minus 1 minus 1
because it is IE1
1.
minus IE5 minus IE6. That is equal to 0. So
Yes, sir.
this entire row is multiplied by this entire column and giving you this value. This is what matrix multiplication means. So this is the thing for node A. So the equation for node A is represented as a one row in this matrix, and these are the variables, and this is the resultant value. Okay. So now let us write for the next row. For node B, what you will write?
Minus 1 1 1 0 0 0.
This for node B. For node C, what you will write?
0 0 minus 1 minus 1 0 1.
Okay. Node D, what you will write?
0 minus 1 0 1 1 0.
Okay. Now, so now from this you should try to understand why I told you must write it in an order, because this corresponds to this. It should be in the serial, in a ascending fashion, so that you can directly write it into the matrix. So is that part clear?
Yes, sir.
Yes, sir. Yes.
So you must write it in order. Okay. Next thing I want to ask you guys is, so what is the dimension of this matrix?
4
4
into 6.
cross 6.
Let us. So it is 4 rows, 6 columns. What is the dimension of this matrix?
6 cross 1.
6 cross 1.
And what is dimension of this matrix?
4 cross 1.
4 cross
Cross 1.
Cross 1. Okay. Then, can you tell me for one particular column, what is the sum? What is the sum of the elements of this column?
0.
For the other columns, how much is the sum?
0.
0.
Okay. So, we know that the sum of the elements of the columns are 0. Okay. Now, what happens is, if I do this, if I rub this, what will happen then? Will I
the
not be able to know what should be in the bottom row?
We can
No, sir.
calculate it, sir.
You can calculate. So that information, this information which is over here, right, is already available in these three equations. These three equations have the information of the fourth row. So the fourth row is redundant. It is like extra. It is like needless information. Okay. So to get the actual total information, total representation, these three rows are sufficient. They are sufficient for me. Okay. So these three rows together form my incidence matrix, and that is written as like this. So you will write your incidence matrix as 3 rows, 6 column. Okay. With these values. So 1 0 0 0 minus 1 1. This is minus 1, 1, 1, minus 1, 1, 1, 0, 0, 0. And this is 0, 0, minus 1, minus 1, 0, 1. 0, 0, minus 1, minus 1, 0, 1. Okay. So any doubts in this till
Yes,
now?
sir. No, sir.
No doubts, no?
No,
No, sir.
Hope this matrix thing is clear.
Yes, sir.
Yes, sir.
yes, sir.
So, so this is the thing. Now, okay. So we can write it as A. This matrix A into matrix I E is this matrix 0. So this is your matrix A.
Yes, sir.
This is your matrix A. What is your matrix IE?
I1 to I to 6.
Okay. So this is your matrix IE. Okay. And this is your 0 matrix. Okay.
Yes, sir.
So this is your multiplication A into IE becomes 0. Now there is another relation which is that A transpose Vn is equal to Ve, where
Yes,
n
sir.
is the voltage, Vn is the voltage at the nodes.
Node voltages.
Node voltage. And what is Ve?
This is the element voltage.
Oh, element voltage. Correct. So this is done. Now there's that relation also. You can derive that relation. So we will now. What is a tie set? What is tie set?
A tighter matrix can be found by applying loop analysis. Okay.
Okay. Suppose we use our first thing only. Okay, so I'll draw the most like the tree which I recommend to use, that is A, B, C, D, 1, 3, 2. Okay, so how many tie sets can we make?
3.
3. So in tie set, what we are doing, we are actually doing KVL, right?
KVL. We are applying the KVL.
And how we are doing it is we are forming a loop. We are
Loop question.
forming a loop. So if you understand what the definition of a tree is, you connect all the nodes of the network. There is no node that is left untouched. Each node is connected to the other node. There is a path, but there is no closed path. So now when I'm going to form a tie set, I am basically forming a closed path. So if I do this, if I connect like this, okay, I am forming a closed path is formed. So that is my tie set. All right. Any queries in that?
Yes, sir.
So now you like there is a reason why there is a convention or why you must do numbering in some particular order, etc. So so this is tie set 5. Okay, this is tie set 5. So what numbers you will give for tie set 5? What numbers will you give?
1 to 5.
So tie set for 5 is formed by 1 to 5, and there is some you give either 1, -1 or 0. No, how will you give?
If the current is in the direction of the link, then it will be positive.
So link has one direction. If the currents of the other twigs which form the tie set are also in the same direction, then it is positive, right? So we write 1,
Yes,
Yes,
1.
sir.
sir.
This is for branch 1. This is for branch 2, branch 3, branch 4, branch 5, branch 6. So we write 1, 1. 3 is not there, so 0.
0.
4 is also not there, 0. 5 is there, so 1. Branch 6 is not there, so 0. And since 5, 1, 2 are all in the same direction, we give it the number 1. All right? So this for tie set 5. What is for tie set 4? Tie set 4, if I write,
2,
let me draw.
2, 3, 4.
Let me just draw. So it will be 2. This is my tie set 4. And this is 3. So what will be the numbers given?
2, 4, 3.
2, 3.
2, 3, 4.
2, 3, 4. Okay, so branch 1 will get what value? 0, 1, how much?
0.
Branch 1, 0.
0. Branch 2 will get how much?
1.
Perfect.
Why?
1. Because in tie set 4,
Direction of 2 and 4
there
it is in the same direction.
1. So branch 3 will get what?
-1.
-1.
Branch 4 will get what?
1.
1.
What will branch 5 and branch 6 get?
0,
0.
0.
0, 0. Right? Okay. Now what about tie set 6?
1, 3, 6.
Over 6, it is formed actually by okay. This is how tie set 6 is formed. This is A, this is B, this is C. So now, and this is D. D is not coming to the picture. Okay. So what numbers you give for tie set 6?
1, 3, 6.
Yeah, 1, 3, 6. But what numbers you give over here? For branch 1, branch 2, branch 3.
1, 0, 1, 0, 0, 1.
For branch 1, you give 1. For branch 2, it is not there, so you give 0. For branch 3, it is in the same direction as branch 6. So you give it 1. For branch 4 is not there, 0. Branch 5 is not there, 0. Branch 6 is there, so you give it 1. Okay. Is this clear?
Yeah.
Yes, sir.
Okay, so basically, this is how we write the tie set matrix. But there's something which I want you to keep in mind is, you must write it as first tie set 4, then tie set 5, then tie set 6. Here I've done it ulta, like I've first done tie set 5, then I've done tie set 4, then I've done tie set 6. But instead it should be tie set 4, then tie set 5, then tie set 6. That is a better way of writing. Okay.
Yes.
So the tie-set matrix B, okay, the tie-set matrix B, what will it be written as? What will be in the first row?
tie set 4, 0, 1, minus 1, 1, 0, 0.
It will be 0, 1, minus 1, 1, 0, 0.
Plus 1, 0.
Next row, what will be there? Let me ask someone else. So Narasimha,
Yes, sir.
what will be in the second row?
Second row it will be containing 110010.
Okay, then Akash, what will be in the third row?
101001.
Okay. And Hota, like what is the dimension of this matrix?
3 cross 6, sir.
3 cross 6. Okay. Now, what does this signify? This row which you have written, what does it signify? Does it signify current? Does it signify voltage?
Voltage.
Voltage. Which voltage?
This is the element voltage.
Element voltage is correct. So now let me draw tie set. Assume tie set 5. Or this tie set 6, let us consider. So this will be plus minus VE1. This is plus minus VE3. This is plus minus VE6. Why? Because current is flowing from the positive to negative voltage, right? So this plus minus V1, this plus minus V3, plus minus V6. So if you apply KVL, what you will get over here? What will you get? How will you write KVL for this loop?
Plot V1, plot V2, plot V5 equal to 0.
V6. So V5 is V6 it is.
And V5,
This 6 na?
for which loop?
But I said
5, na?
but I said 6.
Sir, tie set 6, that is basic, V6.
Okay. So that means what do you get? This B matrix is for what? You have B matrix here. You have the voltages here. This is equal to 0. Okay. Any doubts in this?
No, sir.
Okay. So what is the dimension of this? What is the dimension of this? Okay. What is the dimension of B?
3 cross
3 cross 6.
What is the
3
dimension of?
cross 6.
Yes. What is the dimension of VE?
6 cross 1.
6 cross
6
1.
cross 1.
This has to be 3 cross 1.
3 cross 1.
Okay. So, yeah. So is this clear?
Yes, sir.
Yes, sir.
There's another relation for the currents for the same tie-set matrix, that is B transpose IL is equal to IE. Okay. B transpose IL is equal to IE. So now we have, what have we done? We have discussed for tie-set matrix. How do we make it? How do we first make a tie? How do we make a tie? Is we just add a link to the tree, and then the closed path that forms the tie set. Okay. And from that tie set, we are writing all these equations. So Yeah. So now, what is there after tie set? What is next after it? Who will tell me? So you study tie set. Next, what did you guys study? Did you guys study cut set?
Yes, sir.
Yes, sir.
Okay, what is a cut set?
Try to cut the total circuit in two halves.
Okay. So now, um, let me draw
And it must contain one tree.
one tree,
One, no, twigs.
one twig. Yes. So let me draw a circuit. A, B, C, D. Okay, 4, 5, 6 in this direction. 4, 5, 6. So now, if I want to make a cut set, where should I cut?
Sir, in this way we cut one twig must present.
What? Okay, so where you give me an example. Which one should I cut?
A, C, and D, sir. 3 cuts.
E cuts at A, C, and D. I have to cut it.
No, sir.
You don't have to cut it node. No?
Yes, sir. Yes, sir. Yes, sir. A. In A side we take a cut.
So here,
No, sir. No,
No,
sir.
sir.
In
6,
AB.
1, and
In the
5 branch elements.
so first I
6
cut
and 5.
this cut set 1. Okay, this one. So I have to cut it, right? So I have to cut. So now I'm moving. It should be only for one twig. So like this, I'm cutting it. Okay. This is known as my cut set 1 because it is cutting twig 1. Okay.
Yes, sir.
What will be my cut set 2?
In D point. 2, 5, 4.
This is my cut set 2. What will be my cut set 3?
B, C, D में
3, 4.
3, 4, 6.
This is cut set 3. Now what is the convention? Which will be positive, which will be negative? Assume cut set 1. Okay, what are
Yes,
the
sir.
elements of cut set 1? You have 1 and you have what?
5 and 6.
5 and 6, right? So for currents IE1, IE2, IE3, IE4, IE5, IE6, what will be the values? What will be 1, 0, 0? What will it be for cut set 1?
I1 is 1.
Okay.
I2 to 0. I2 3 0. I2 4 0. I5 minus 1. I5 6 minus 1.
Okay. What about Akash? What about Mia, Farhan? Hmm? So Akash, can you tell, is it correct what he told? Is this correct or wrong?
So is the convention that the arrow towards the cut means -1, right?
Okay. No, now let us see something else. Now what happens is, instead of here 6, I write my 6 over here. Instead of 1 over here, I write 1 over here. Instead of 5, I write 5 over here. Then I'll rub off these arrows. Okay. So it is the same, right? It is the same. My current is in same direction, this direction, this direction. It is the same. Now what will be for cut set 1? Now in this case, the current is going towards cut set 1. It is not going away. So what should I do in such a case?
Take positive.
For which one should I take positive?
Towards cut set 1.
What will be? For IE1 will be positive, or IE5, IE6 will be positive?
I1 is positive.
I1 is positive.
So IE1 will still be positive. And IE5, IE6 depends on the direction of IE1. If IE1 is going towards the cut set, then IE5, IE6 also should go. If they are going the opposite direction of IE1, then you give it a minus sign. Okay?
So it depends on the twig that we are cutting, right?
It depends on the twig. Yes, on the twig you are cutting. Yes.
Cutting or yeah, yes, sir.
So your twig is the one which decides your, how you will give the sign. Your twig is the main guy. Your twig is your reference. Okay? Based on your
Yes,
reference, you
yes,
decide
sir.
the signs for the other links. Twig is the primary thing, links are the secondary. Link direction depends on the direction of the twig. Now we will consider cut set 2. So what you will write for cut set 2?
0, 1, 0, -1, -1, 0.
Cut set 2 is 0, 1, 0, then
-1, -1, 0.
okay. Anyone has doubt in this?
No, sir.
Okay, what about for cut set 3? Let Mia answer. She will not answer anything.
Yes, sir.
What is for cut set 3?
Sir, 0, 0,
0, 0,
1,
yes.
1, 1,
Yes.
1, 1, -1. 0, 0, 1, 1, 0, -1.
Okay. Fine. So now, this is my cut set matrix. So my cut set matrix is given by 1, 0, 0, 0, 1, 0, 0, 0, 1, 0, -1, 1, -1, -1, 0, -1, 0, -1. Okay. So, what is the dimension of this?
3 cross 6.
3 cross 6.
Okay. So what can you observe if you just see the first 3 columns? You just see
The
this.
sum is
Identity matrix.
It is an identity matrix, right? Any doubt in this?
no, sir.
Yeah, so that's why it is preferred to use the numbers 1, 2, 3, the first numbers as your twigs, the next numbers as your links. It is the the best practice while solving these sums. But in case they have given you a tree where the twigs are 1, 4, 5, then you can't do anything. Then you cannot change. But if you are given the opportunity to decide which are the twigs and which are the links, then you must choose the first few elements as your twigs and then remaining as your links. All right. Yeah. So now for this, we have the relation that is, so this will be what? This will be your Q. Will be multiplied by what? Multiplied by your link current or your element current or your link or your node voltage or your element voltage. This multiplied by what?
Link current. Link current.
Link current. How many link currents are there?
6.
Huh?
2, 3, sir. 3.
3. No, I made a mistake there. So this is your 3 rows and 6 columns. And your link currents are 3 only, right?
6 into 1, sir.
Correct. Should be what then? This
It
should
6
be
into
will
1.
be elemental currents.
element currents, which is 6 cross 1. Okay, and that should be equal to what?
Link currents.
This should be equal to link current.
No, sir. 0.
Yeah, this should be equal to 0. Okay. So your Q into I should be equal to 0. So now, yeah, there's another relation that is Q transpose V element voltages should be, no, your tweak voltages will be equal to your element voltages. There's another relation. Into right W. Okay, so this is something else. So if you need this relation, you'll have to try to remember this. So this meeting will end in 2-3 minutes. So another thing I'd like to share is the drive link and all. So these are the channel link and a drive link. Okay. So this session will be uploaded on YouTube, and these notes will be uploaded on the drive. So you can access these notes later as well. Okay. So till now, anyone has any question?
No, sir.
No? Okay. So then, okay, so then we'll start solving the sums. So we'll just see one more aspect also.
Sir,
Yes.
sir, can you please explain how you took the elements in the first cut set 1? That signs I'm getting confused.
This cut set 1, right?
Yes, sir.
Okay. This is my cut set 1. So my main thing is my twig. Which is my twig?
So between A and B.
That is my twig 1, right? So now I am actually applying KCL at my cut set 1. So KCL at cut set 1 has to be satisfied, right? So if this is the current which is entering it, that should be equal to the currents leaving it. This entire thing is become my cut set. This entire thing is my cut set. And applying KCL for this cut set. So if I apply KCL to this cut set, what I get? I will get my IE1 current entering in should be equal to the current leaving out. That is IE1 is equal to IE5 plus IE6, right? And when you further simplify, you can write it as IE1 minus IE5 minus IE6 is equal to 0. And that is what this first row means. IE1 means 1, IE5 is minus 1, IE6 here you have minus 1. So this is my cut set 1, right? So I am applying KCL at this cut set 1. So at cut set 1, what current IE1 is entering in, current IE6, IE5 are leaving it. So IE1 is equal to IE5 plus IE6. Okay, this is the current entering in, this is the current exiting. So then when I take these to the left hand side, I get IE1 minus IE5 minus IE6 is equal to 0. And that is reflected in this first row of this matrix Q.
Okay, sir. It's clear. Thank you, sir.
So now I'll solve the sums. I'll start solving sums. So we have to find for this one. Let's take this. So in this one, the solid lines are my twigs. Okay. And the dashed lines, these are my links. So now we want to find cuts. So now we want to find the cut set. So what will be the cut sets? How many cut sets will be there? Nia, Farhan, how many cut sets will be there? Narasimha,
2, sir.
which and all?
At node 2, 2 and 5. And at node 4, 3 and 4.
Okay, node 2 and node 3 and
That
4.
is cut set 2 and cut set 3, sir.
Cut set 2 and cut set 3. Cut set 1 won't be there. So what is cut set?
There
Cut
are
set,
only two possible. There are only two possible, cut set 2 and cut set 3. One is
Right.
not possible.
why?
So if you take the one, then it causes the two twigs simultaneously.
No,
We are taking a cut set across 2 and 5, but
no.
to not get cut set at the node 3. Because if we have cut set, then two twigs are involved. But in cut set, only one twig is involved.
Okay, okay, we can disagree, but I'll say there are 3 cut sets. Okay, there are 3 cut sets. So one cut set is your normal cut set. This one, you're cutting only one twig. This another cut set, you're
Yes, sir.
cutting one twig.
4. Yes, sir.
This is also another cut set, right? I'm cutting only one twig.
Yes,
Oh,
sir.
sir, yes, sir, yes, sir, yes, sir. Yes, sir. In middle also we can cut, yes, sir.
So this is my cut set 1. This is my cut set 2. This is my cut set 3. Okay.
Sir.
Yeah. So now, now let us see how you will solve this. So what will be the equation for, so we have cut set 1, we have cut set 2, we have cut set 3, we have IE1, IE2, IE3, IE4, IE5, right? So what will be the coefficient?
Yes.
For cut set 1, I1 will be how much?
I1 is 1.
What will I2 be?
Zero.
I2 will be 0.
What will IE3 be?
Minus
Zero.
1.
IE3.
Minus 1, sir.
Zero,
Minus
sir.
1.
IE3 will be zero. Right?
For cut set 1, this 5, 1 and 4 only come.
Yes, sir. Yes, sir. Yes, sir.
IE3 is zero, sir.
What will be
I3 0.
IE4? What will be IE4?
1.
Minus 1.
Why 1?
Positive
Why
2.
minus 1?
No, sir. 1. Sir, 1, 1.
No, positive 1.
So, Kavya, why minus 1? Or why whoever said 1 by 1?
Because it is coming into the twig, into the cut set, that current.
For IE4, right?
Yes,
But
sir.
for 1, it is leaving the cut set.
So that depends on the direction of the current. So if from 3 to 1, the current is coming from 3 to 1, so
Okay.
we took that as positive. It is coming into that cut set. So here from 4 to 1 it is coming. So it is coming into the cut set. Right?
Okay. Okay, you're
So
considering like that.
yes, sir.
And what about for 2 to 3, 4, 5? It is also coming into the cut set, no?
No, sir.
So, sir, always take the twigs, the direction of the twigs. To the cut set, 1 is incoming, so take it as a positive.
No, 1.
In 4,
Listen. For cut set
1
1.
is positive, and in 4.
No, for
Sorry.
cut set 1. For cut set 1, 1 is going out of the cut set, right? If you see the arrow, it's going out of the cut set.
Sir, if you take the previous part before the cut set, we can
Then it
take
is
before the
coming-
cut set.
Then it is coming in.
Then incoming the cut set. So take the
Yes.
incoming as positive 1.
No,
Then
will
in the
consider
5 is outgoing.
Okay.
Sir, who will tweak? So anyone who can take after the cut set or before the cut set.
Left side or right side, any one side we can consider and choose the directions, incoming and outgoing.
Okay. So what I will recommend is you like assume I have made a cut set over here. And I've assumed for 1 is going out. That is the left of the cut set I have given. So this arrow also should be at the left of the cut set. This arrow is already to the left of the cut set. This arrow is already to the left of the cut set. So all the arrows should be at one side of the cut set. I consider like that. Okay. Then I put the numbering. I1 is going left. So that is going out of the cut set. So that is my reference. 1. IE4 is also going left out of the cut set. So that also is 1. IE5 on the other hand is entering into the cut set. So that will be minus 1.
That is minus 1.
Okay.
Yes, sir.
Now for cut set 2, what will you do?
0, 1, 0, 0, minus 1.
0, 1, 0, 0, minus
0,
1.
minus 1.
Minus 1.
Okay. For cut set 3,
Yes, sir.
what will you get?
Cut set
0,
3 is
0,
0.
1.
Take as
Minus 1, 0.
What?
cut set 3.
0,
Take as 1.
0,
0,
0,
0,
1, 1, 0.
1, minus 1.
0, 0, 1, 1, 0.
1, 1, 0, yeah.
So all the arrows you should consider to be at one side of the cut set. Then you must give the the polarities, okay, or the direction. Yeah. So I hope this thing is clear because this is what confused me also last time, like when I was solving. So I was thinking if I draw current this direction is coming into the cut set. When I'm drawing the arrow in this direction, it's going out of the cut set. So which one should I consider? So that's why I finally decided I will draw cut set and I will draw arrows to one side of the cut set. And based on that, I will decide the directions. Okay.
Yes, sir.
So these doubts will come when you try to solve it just without seeing it, then you will get such doubts. Now let us go to the next question. Okay. So so if you look at this, they have told us to find the reduced incidence matrix. So what is that matrix? What is the letter we use to denote that?
Yes, sir. A.
Okay. So now you have to find a reduced incidence matrix. So what will be the dimension of this matrix? Huh?
4 cross 6.
It is
No. Number of nodes.
reduced.
1 will be the reference. Hence, we can take 3 cross 6.
Okay. It is actually incidence matrix is 4 cross 6, but the reduced incidence matrix is 3 cross 6. Okay. So now
Yes, sir.
we'll consider node 4 as a reference. So now we must do for node 1, node 2, node 3, and this will be my branch 1, branch 2, like that. Okay, I'll make branch 3, branch 4, branch 5, and branch 6. Okay. So for node 1, what is it? What you will give it?
I1 plus I2 minus I3 equal to 0.
I1 plus I2
Plus I3 minus I3 equal to 0. Minus I3 equal to 0. So 1, 1, minus 1, 0, 0, 0.
for node 2.
Node 2, 0, minus 1, 0, minus 1,
minus
0,
1, 0,
minus 1.
minus 1, 0, minus.
Okay, for node 3.
Minus 1,
So
0,
minus 1,
0, minus
0.
1, plus 1, 0.
For 4, how much it is?
Minus
For
1,
4, minus 1.
0. 4 is outgoing.
So it is
Yes,
And this is
plus
plus.
1.
Plus 1, sir. 4 is plus 1.
For 5.
4 is
Minus 1, 0. Minus 1, 0, 0, 1, minus 1, 0.
Yeah. Okay. So is this clear?
Yes, sir.
yes, sir.
Okay. Now
actually, I have a question. Right? The
just
first question.
This one, let me just copy this. Yeah, you were saying in the first question?
Here, cut set 1, 2, 3, right? Anywhere can I take?
So anywhere can you make a cut set, right?
Yeah, CS1. I mean, the nomenclature CS1, CS2, CS3, right? If it is
Uh-huh.
not mentioned, how can I do that? Because it's this matrix is going to vary if I change these cut sets, right?
Yeah, it will vary. That's why I tell you to put 1 first, then 2, then 3.
I mean, CS1 we have taken for the node 4, right here.
No, CS1 you have taken for your twig one. You have not taken it for any node.
Yeah, the twig one. Yeah, correct. So
Yes.
there we have three, right? Three, right?
There you have what?
Three twigs we have, right? All three.
No, cut set 1 has been taken for twig 1 and for links 4 and 5.
Okay.
Right. See, if you see, cut set means what you're dividing the circuit into 2. You can divide the circuit also like this. But this is not a cut set because it is dividing more than one twig. So there's only
Yes. My question is a little different, right? I'm saying that instead of CS3, I would have named that as CS1.
okay. That you can do because that is given the number 3, right? It is given the number 3. So this convention it should be cut set 3.
Okay. Okay.
So like in the question, they will give you the numbering, which is cut set, which is 1, which is 2, which is 3, all that they give. Then you have
Okay.
to follow the ascending order. First you do cut set 1, then you do cut set 2, then you do cut set 3. In case your 1, 2, 3 were your links and 4 and 5 were your twigs, then you should have done cut set 4 first, then you should write cut set 5.
Okay. Yeah. So we should follow that number.
Yeah, you should follow that number. Because otherwise, how will someone know that which row corresponds to which cut set? They will not know, right? That's why you have to write it. Okay. Yeah. So let us go to this question. So again over here, we have to find the cut sets. So what will be cut set 1? How will I draw cut set 1?
2, 4.
At the branches 1 and 4. Cutting 1 and 4.
Okay. Cut set 2.
2 and 4.
Cut set 3.
3 and 4. Straight.
3 and 4.
Okay. So this is my cut set 1, cut set 2, cut set 3. Okay. This is my IE1, IE2, IE3, IE4. So what is cut set 1? For cut set 1, what is it?
1, 0, 0, minus.
For cut set 2, what it is?
0, 1, 0, 1.
For cut set 3, what it is?
0,
0, 0, 1, 1.
1, 1.
0, 0, 1, 1. Okay. So, yeah. So this is how you get it. So these are very simple, right? You guys are very able to do it fast. Huh? Okay. So now let's go to the last question, I think. Yeah, this is the last question. So in this question, they have told to find a tie-set matrix, loop matrix. Okay. So you have to find the tie-set matrix. So how many tie-sets will be there?
2,
Which and all?
6 and 7.
Okay,
I
so
said 6, I said 7.
sorry.
No, sir. I said 6 and I said 7. Numbers, sir.
You have tie-set 6 and tie-set 7. Yes, correct.
Yes.
And 7. So you form tie-set 6, right? So in tie-set 6, what are the elements in tie-set 6? Okay, I'll ask someone. Wait. Don't answer. So, Suresh, what are the elements in tie-set 6? Huh?
No,
Sorry?
I don't know. Sorry.
Okay. What about Mia for Farhan in tie-set 6? Narasimha, Ina,
Sir, -1, 0,
-1, 0.
and then it is coming again -1,
-1,
0,
0.
1, -1.
And there should be 7, right? This is branch 1, branch 2, branch
Last is again 0.
branch 4, branch 5, branch 6, branch 7. This is 0. So how do you decide which is the reference direction?
Sir, I took anti-clockwise as a reference direction.
Why?
Sir, branch 3 will be +1, sir.
No, let him answer. Let him answer.
I
Yes.
took anti-clockwise as a reference. Like, in
Yeah.
just as we do in KVL, I just took sir
Okay.
like whether we can. Then I did the same.
Okay. So your tie set is formed by which is the thing which is forming your tie set. So what exactly is a tie set?
So, whatever whenever we get a tree, when we join, but
Okay.
using
So
the
I
link.
am joining this link. With the link, I am
Yes,
joining it and I'm forming a closed path. That is why I'm
yes, sir.
forming a tie set, right? So for tie set
Yes,
6,
sir.
this is not the closed path. This is not the closed path because the link is open. Right? Only one link I'm adding, right? So
Yes, sir.
this is my tie set 6. Now, depending on the link direction, that is the direction which I must consider. So this is my direction. So the direction then is
Okay, sir.
clockwise. So now you tell me what will be. So first thing is your 6 will always be positive. Your link will always be
Yes,
positive.
sir.
So 6 is positive. Then tell me what 1 will be.
1 +1
Why?
because
One
+1 is
will
a minus
-1.
-1, sir.
Okay, branch 2 is 0. Branch 3 is what?
Branch
-1.
3 is again +1,
Okay, plus
+1, sir.
branch 4.
Branch 4 is 0. Branch 5 will be -1,
Okay,
and then branch 6 is +1.
okay,
Branch 7 is 0.
okay. Correct. Now we have to do, yeah, fine, we can mute. Now we have to do tie set 7. Okay,
We'll take the whole loop, right? The complete loop.
Akash, yes, yes. So we are adding this. We are adding this. So we have to consider this entire loop. Okay. So Akash, you tell me what should be the numbers given.
Yes, sir. First of we have one will be positive,
Okay.
7 will be positive.
one minus one,
Okay.
three will be minus one,
Okay.
4 will be plus one,
Plus
Okay.
1.
5 plus one,
Okay.
6 will be 0, 7 will be plus one.
Yeah. Great. So this is the tie set. So you guys have formed the tie set matrix. Yeah. So
Yes, sir.
that's all questions we have for today. So any other doubts you guys have?
No, sir.
So still
Yes, yes.
cut set is being little confused. Cut set, how to
Uh-huh.
consider the directions.
Yes, yes. Okay,
It's little
so
confusing again.
okay, just assume. So let us say I do cut set for this one. Okay, I do a cut set for this. Okay. Let me paste it again. Suppose this is my cut set, okay? And I draw a straight line. I'm doing cut set 3, okay? Cut set 3 I'm considering. So I draw a straight line. Okay, this is my cut set 3. Now when I initially look at it, what I will see that this is going away. This is also going away. This is entering. What I will add is, I will give, for 3 I will give 1. For 6 I will
1.
give minus 1.
Minus 1.
7,
7, 1.
6 also I will give
1,
1.
1.
6 also I will give 1. 7 I will give minus 1. If I use this way, that if I see just on what the line has cut, and I tell that if all are going out, whatever is going out is 1. Like if this is going out, then this which is going out also is 1. This which is coming in is minus 1. But this is not correct because all the arrows are not in the same direction of the cut set. Like here, this on top, this arrow on top. These are in the bottom. Okay. So what I do is I draw a cut set. I have drawn this cut set. It is drawn. Now for my twig, what I am actually cutting is my twig. That is the main thing. My twig is on top. So the arrows for the links also should be on top of the cut set. So that's why this arrow will be going down. This arrow also will be, this arrow will be going.
Up.
This arrow will be going up. So that is why 3 will come as 1. 6, which is in the opposite direction, will be minus 1. And 7 will be 1. Okay.
Okay, sir.
Hmm.
Sir, what if we do the cut set for fourth twig?
What if we do the cut set
Like
for? 4.
fourth cut set 4.
Okay, for cut set 4. Now cut set must divide it into 2. Okay, it must divide into 2. I didn't draw. One thing is I know I must divide this. And it must not
Yes,
go
sir.
through any twig. It must not go through any twig. So it cannot go over here, cannot go here, it cannot go like this, it cannot go like this, it cannot go like this. So the only option it has is like this.
Yes, sir.
Okay.
So number of cut sets is always equal to the number of twigs.
Yes, yes.
Is it correct?
Now I've drawn this. Now if I see, This is the top of my cut set, this is my bottom of my cut set. And my twig arrow is below. So this also has to be below. So this will be like this. Based on that, then I will decide the convention. So this is my positive one, this will be my negative. This is leaving my cut set, this is entering my cut set.
Okay, sir. I got it, sir.
Okay.
Thank you, sir.
One last doubt.
Yes.
So let us assume that 6 is not a link but a twig.
No, we cannot
So
assume
if
that,
you
because then the loop will be formed.
yeah. Okay. Yeah. Yes. You just said the number of twigs will be equal to number. So I just wondered what if this is connected. So yeah, that's clear.
Yeah. Okay. Okay. So then no other doubts, we can end here. Yes.
So while we are doing cut set, right, we should be able to separate that from the diagram, right? That is only when we call this cut set.
Yes, we are actually dividing the circuit into half.
Okay, so some part of that we can able to remove that from that.
Yes.
Okay.
Hmm.
What is the application for this theory? Where we can use this?
Yeah, like when you are solving these very large networks, these things will come into picture where you will have to use matrix multiplication and division, etc., to solve the circuit. So for you currently, you guys, you are just been given some basics understanding of all this. But then later on in power systems and all, they use these matrices a lot. So there, they will form what you say, the network. Like a power system is basically a network. So you have one generator over here, another generator over here. They are connected by some transmission line which has impedance Z. Then over here you will have some sort of load, etc. Like many things will be there. So it's a complete network. So for that network, they form these graphs. Okay. And they will, they will use this sort of concepts to solve these large networks. So their matrices are very important. So you guys have not studied power systems till now?
No, sir, it's 30.
Okay, yes. So there it comes. Their matrices are used a lot. Exactly, I haven't used cut set and these tie set from while even studying power systems. I haven't used, but I have used matrices a lot. Like these matrix, you will form. You have an impedance matrix. You have an admittance matrix, and then various calculations you can do.
And these magnitudes also might vary, right? From branch to branch, maybe application to application, it might vary.
Which magnitude?
I mean, the current magnitudes, what we are talking about now, just we are focusing on directions.
Current will vary. Yes, that's true.
Okay.
Okay. Okay, so there's no other doubt in the meeting, huh? Okay. Thank you, guys.
Yes, sir.
Thank
Good
you,
night.
sir.
Thank you, sir.
Thank you very much.
Thank you, sir.
Welcome. Bye.
Thank you, sir.
Thank you.